So this tan to the -1 means arctangent. So when we're taking the derivative of arctangent cubed, you start off with bringing the 3 down to the squared power, carry the inside along, and then you multiply by the derivative of the arctangent, which is that. Subtract. So now here, this was the cube is the most outside function. This one, the arc sign, is the most outside function. So 1 over the square root of 1 minus the stuff squared. So the stuff is e to the 2x. And then I multiply by the derivative of the e to the 2x, which is e to the 2x times 2. And then here, the x to the 4th is the inside of the arctangent. So it's 1 over 1 plus x to the 4th squared times the derivative of x to the 4th, which is 4x cubed. Okay, so this one here, the cosecant is the most outside function, and all of that's the angle. Okay, so to take the derivative of cosecant, negative cosecant, cotangent, and leave room for that angle. So it's g of x to the 4th, g of x to the 4th, and then take the derivative of the g of x to the 4th. So that's 4 g of x cubed times the derivative of g of x, which is g prime. Okay, then moving on to this e guy, the derivative of e to the stuff is e to the stuff times the derivative of stuff. All right, so let's do this one in a different color. So capital F prime. We're going to start off with the derivative of bringing down the 3. Carry the cotangent of g of x along. And that's also to the squared power. Now we're going to multiply by the derivative of cotangent, which is negative cosecant squared, parentheses needed, right? Carry the angle along, and now take the derivative of the angle, g prime. And then subtract, so let me just go down to the next line. Oops, to take the derivative of 3 to the g of x is 3 to the g of x times ln of 3 times g prime of x. Okay, so now we're going to take the derivative. Let me make it a little bigger here. So I want you to recognize that there's product rule here. So it's 3x times y. Such an easy thing to miss. First d second plus second d first equals derivative of cosh is sinh. Carry the angle and then multiply by the derivative of the angle. Minus derivative of y cubed is 3y squared y prime plus, make some room here, the derivative of just regular tangent to the 4th. So that's 4 cubed tangent of x, and now derivative of tangent, which is secant squared. Okay, so now we're going to identify where the y prime terms are. So there's 2 of them. So I'm going to add this to the other side. So I have 3x y prime plus 3y squared y prime. And then I'm going to move this to the other side by subtracting. So I'll set minus 3y, and then I'll plus the sinh x cubed 3x squared, and then plus this 4, and I could keep it out there, or I could put the cube there, because they mean the same thing. So now I'm going to do 2 things at once. I'm going to factor out the y prime out of these 2. I'm just going to rewrite this. Plus 4 tangent cubed x secant squared x, and I'm going to divide by, when I pulled, oops, that's a tangent. When I factored out the y prime, I've already got a 3x plus a 3y squared. Okay, so this one here, find the y prime, and then, because that's going to give you the slope, and they already give you the point, so I just need the slope, which is the y prime. So let's go take the derivative. So derivative of x is 1. 2y, y prime is the derivative of y squared. Be careful taking the derivative of this. It needs product rule. So it's first d second plus second d first, which is just a 1. And then taking the derivative of this over here, again product rule, first d second plus second d first. Okay, so let's identify the y prime terms. So y prime terms are here, whoops, here, and here, and here. So I'm going to subtract this one to this side. So let's, so I'd have 2y, y prime, plus 3x, y squared, y prime, minus 3x, y prime, equals, okay, so I got this 3y here. I'm going to subtract the y cubed and minus the 1. So at this point here, I think it's useful. I could have done it right here, but now is a great time to plug in the 1, 1. So plug in x equal 1 and y equal 1. So I get 2 times 1 times y prime, so that gives me 2y prime, plus 3y prime, minus 3y prime, equals 3 minus 1 minus 1. So both of these y primes, they cancel each other out. So I get 2y prime is equal to 2. So y prime is equal, y prime is equal to 1, added wrong there. Y prime is equal to 1, 1, come on, 1. And so then y prime is equal to 1/2. Doesn't answer the question. Remember, you need to go back and answer the questions. What's the equation of the tangent line? So I get y minus 1 is equal to 1/2 x minus 1.